Okay, record started. So let me show you the easy way to do the graphing. Then we will start in the old way, traditional way. So this is Desmos. You can just type in the address in your browser and you see, look, then you type the function, you see how it looks like. Okay. You can zoom in to see the details. You can also add a new line to see the cosine. Okay. So look at it. The red one is a sine function that starts from 0, then it's getting higher until reach somewhere here. Then it's getting lower, higher, lower, higher. It's repeats itself every 2 pi, okay? So is cosine. But cosine begins with a high value, then it decrease, then increase, then decrease, then increase. Okay. Right now you just need to get a sense what that function look like. We are going to draw them again on paper using the traditional way. Okay, this is our sine function. What if you times this function, have a number times this function, for example, 2? Do you guys see the difference?
Yes.
It just has a higher amplitude, right?
Very good. Exact term, amplitude. So originally you have here, you have the y value as 1, the x value as pi over 2. However, if you times 2, look, for the same x value, it doubles the y value. Okay, look, the y value now is 2. Okay, it amplifies the curve. Okay, originally you have -1 here, but if we times this -1 by 2, this -1 by 2, this doubles down. Okay, now you see the y value is also -2. Did someone make some noise? Okay. So what if we add a different value to x? How would x would change? For example, let's add a simple value 1. Okay. Now do you guys see any difference?
There are more points on the graph.
Kind of. Do you see? Let me delete this 1 and add a 0, which changes nothing. This is the original graph. Okay. It goes across origin. But if we add a 1 here, do you guys see some difference? Originally, it goes across the origin from here. Now it shift left by 1 unit, right?
Mm-hmm.
Everything shift left by 1 unit. Okay, this is the original graph. Right now, I'm just giving you an impression what will today's class will look like. We are performing it on the website. And after we're done with the website, we are going to perform on paper to do it in the traditional way to figure out the details. Okay. Look. You can also try on your computer. Originally it's like this. If you add 1, shift left. Original like this. If you add 1, shift left.
You can have them both on at the same time. Just add another one, right?
I'm
To see them
sorry.
both. To see them both, you can just add the other one as a second line to graph,
Oh yeah,
right?
you're right. Okay. So this line, blue line this is blue or green? I apologize.
It's green.
Oh, it's green. So silly. This green line was originally here. If you add 1 to the x, it shift 1 unit to the left. Okay, if we add 2, you will see it shift 2 more units left. If we add 3, add 4, add 5, add 6, okay, add 7, add 8, add 9, add 10. Okay, it's shifting more and more to the left. Okay, now you have a good sense what will today's class look like. Does anyone has any question before we continue to the paper, lecture notes on the paper?
What I have a question. What if you were to like subtract?
Very good question.
Move to the right, technically.
Yes, when you are subtracting number, you are moving to the right. Okay, let's do it right now. Subtract 1. You see, originally you have a green line, then it's moving to the right by 1 unit. Subtract by 2, moving to the right by 2 units. 3 units. Okay. Any question before we continue? Okay, so let's continue to our paper. Stop sharing. Okay. So let's draw those lines on paper. So we are doing it in the old-fashioned way. First of all, we need to find the points on the x-coordinate. So we learned how to find the exact value for the sine functions in the previous class. Okay, let me write down a few numbers. If this is pi over 2, okay, this coordinate is pi over 2. A third of it is this point. A third of this pi over 2 is this point, is pi over 6. Okay, 2/3 of pi over 2 is pi over 3. Okay. So if x is pi over 6, can you tell me what's the y value? Sine pi over 6. Speak out, please. Okay, let me write down more clearly. Sine pi over 6 is what? Can you
30?
tell? It's 1/2, right?
Do you mind showing us how you got there, please?
I'm sorry, what'd you say?
How did you get 1/2?
Okay, so we did it in the previous class. Sine 30 degree is 1/2. Okay. Do you agree with this?
Yes.
Okay, this is what we did in the previous class. We are just using the result from the previous class. And we also figured out 30 degree, if you write it in radian, it's just pi over 6. Okay. Radian. So The half unit circle, 180 degrees is pi. 360 degrees, the whole unit circle is 2 pi, right? Do you guys remember this?
Yes, from the unit circle.
Yeah, cool. So if we have those basic values from the unit circle, then 1/6 of 100 pi is just 1/6 times pi, which is pi over 6. Okay, that's how we get there. By the way, did I answer your question? Okay.
Yes, it did.
Thank you. Let's continue. So if we make the y coordinate at this point to be 1, 1/2 is approximately here. So our first point will be here, right? Okay. How about pi over 3? What is sine pi over 3? Sine pi over 3.
Isn't that square root of 3/2?
Very good. Sine pi over 3, according to our previous class, is square root of 3/2. Okay. Square root of 3, how big is square root of 3? Let me Google it. Okay. So square root of 3 SQRT 3 over 2 is approximately 0.86. Okay. So let's go back, figure that out, which is approximately 0.7. And when the 1 is here, here's 2/3. So it would be approximately somewhere here, okay? So here is 1/2, here is somewhere 0.86. How about the next value, pi over 2? Can anyone tell me what is sine pi over 2? Okay, so if you have difficulty memorizing those numbers, I would recommend you go back to the unit circle. Think about the unit circle we had. Let me just give you a rough sketch. For any angle, the y coordinate corresponding to the sine value, right? So when it was here, the degree, 0 degree has a sine 0 degree. What's the y value corresponding to sine 0? It is just 0, right? Then you move up a little bit. We just figured out sine 30 degree is 1/2. Then we figure out sine 60, you're moving up. Is 8.7. Then you move up vertically. Can anyone tell me if you get a 90 degree here, what's the y coordinate of this point?
It is 1.
Very good. Sine 90 degree, which is just sine pi over 2, which is just 1. Oops. Okay, here it is. Okay, sine pi over 2, which is 1. We reach here already. Then we need to go down. Okay, this is 1. Then what is sine? This is pi over 2 plus pi over 6. This is equal to
Pi over 4.
you're very good. I think it's 2 pi over 3. Because this is 3 pi over 6. 3 pi over 6 plus pi over 6 should be 2 pi over 3. Okay. You are moving. Again, remember the y coordinate corresponding to sine value. When you are here, you have pi over 3, and the corresponding y value is 0.7. How about you move to the other side? This angle is still pi over 6. You just move pi over 6 to the other side. How about those 2 points? Do they share the same y coordinate? I know my graph is kind of ugly, but do you agree they share the same y coordinate?
Yes.
Okay, cool. So if you just move to the left by the same pi over 6, they should share the same y coordinate. So you can just adapt the previous y coordinate here. Okay, same y coordinate with this one. Similarly, you will continue moving until you get here. You move another pi over 6 unit. So this should also share the same y value with this pi over 6. I know my sketch is kind of ugly, but does anyone has any question how we would derive this share the same y coordinate? Because they are symmetric, just because they are symmetric on the unit circle.
You have a minus sign, right?
I'm sorry, can you speak louder?
Different sign, like minus, plus.
Okay. Notice that we are considering sine value. Sine value is only the y coordinate. So if you move to here, your y coordinate are still positive because you are still on the positive side. Okay. Thank you for asking. So for this point, still the same y coordinate. However, if you move completely to pi, which is 180 degree, what's the y coordinate for this point, for this terminal point?
It would be 0.
Very good. You just get rid of the y coordinate by setting it to be 0. Okay, you reach to 0 again. And don't forget that we start from 0. So let's write down the values. 2 pi over 3, you still get 0.7, 0.02. Then 5 pi, this point is 5 pi over 6 because it is 2 pi over 3 plus another pi over 6. You also go back to 1/2, then you have pi, you get a 0. Okay, so now we are done with all the positive values of sine. we also need to go a little bit further to consider some negative signs with pi. What if you move another pi over 6 above the x-axis? What's the y coordinate for this point, just for this point?
-1/2.
Very good. So because this angle is still pi over 6, and you can figure out the length for this side is 1/2. However, it is on the negative side, so it's -1/2. So if you go a little bit further, it's -1/2. Basically, you start your process What if you go a little bit further, another pi over 6? What's the y coordinate for this point? Again, by symmetry, you're just moving this line down. So what you used to have, what y value you have here, it's just the opposite of it, right? So this point is negative square root 3 over 2. Okay, you move this value down. What if you move another pi over 6? Eventually you get to here. Okay. What's the y coordinate for this guy? Can anyone tell me?
Would it be -1/2?
Very good. So it's just the opposite of this point. This angle is 3 pi over 2 because it was 2 pi plus another. Oh, sorry. Because this is a complete pi, then plus another 1/2 pi. You get to this point. So that will be -1. Okay. So we find all the points so far. Again, you see, do you guys remember what we see in decimals? Go up and down, up and down. For the remaining 3 points here, another pi over 6, another pi over 6 here, you can do exactly the same process and get values here, here, okay. So the leftover job is connecting all the dots using a smooth line. Traveling upward, going downward, going downward, going upward until you reach here. Okay. This is how I sketch the graph of the sines, okay, with the assistance of unit circle here. Any question how we get those values or how we sketch the graph? Okay, so no question, let's just continue. Again, now we are adding some kind of difficulty. We're not, previously we're done with y equal to sine x. Okay, this is what we done in the previous page. Now the question add more difficulty to it. What if you have 3 times that value? Look at this graph. 3 times of this guy, everything that was originally positive is getting higher. Or every number gets 3 times. However, when you have some negative values, Negative time values also get 3 times. Also getting lower. Look at my pen. Okay. However, on this graph, the author of this selection note still give us the exactly same coordinates. So what we can do to adjust the higher and lower problem? I tell you a trick. Notice that the y coordinate we use here is the maximum 1. For the same graph, we can just change the y coordinate to the numbers of y coordinate. Okay. For example, originally here it is 1, okay? Originally here, this point is 1. But every number is got 3 times. So we can just put 3 here. Originally here is 1/2. But now it's 3/2. Okay. We can still use the same graph as we did before. We can use the same curve, but this time we changed the y coordinate already. Almost the same graph, but with the y values changed. That's it.
Can you re-explain why it would be 3 instead of 1?
Okay, good question. This was because the author still give us the same coordinates. Look, the coordinates are the same with what we done before. Okay, the author of the lecture notes is very lazy, just use the same coordinates. If we really literally want to draw the graph would look like something like this. Do you agree with this?
Yeah.
Yeah. Everything's 3 times higher or lower. Okay. But this is go beyond the coordinates. This is kind of ugly because to go beyond the maximum of y coordinates already. So in order to make it a little bit nicer, I just use this point to denote 3. So when it arrives with maximum, it arrives at this point 3. When it's in the middle, it's 3/2. So I just kind of use 3 for the maximum, 3/2 for the middle points. So that this graph will still fit into this coordinate. Okay, just to fit into this coordinate, I have to change the y points to everything smaller. Did I answer your question, by the way?
Yeah, I did. Thank you.
Thank you for asking. Okay. I know things may look weird at the first time, but as you think it again, so you will understand that we always have to compromise ourselves. I like the word compromise. Compromise ourselves to do so that things will look nice. Okay. Okay, any question before we continue to the next one? Okay. Next question. We are not only dealing with a negative magnitude A, we are also dealing with a number times x. So let's first look at what it will look like if you times a number on decimals. Okay, let me show you my decimals. Y equal to sine x, y equal to sine 2x. Okay. As you can see, the purple line is y equal to sine 2x. It's shrink the green line by half, okay? Originally it was here. Look, it shrinks to here. Originally this point was here, it shrinks to here. I know it may still look not so obvious to you. So let's perform this shrink process one by one. How about 1.1? Okay, we will gradually increase from 1. Here's 1x, right? Here's 1 times x. We will gradually increase the number 1.2, 1.3, 1.4, 1.5. Just look how the line change. 1.6, 1.7, shrinks 1.8, 1.9.
I think it's supposed to be y equals negative sine times 2x.
Yes, we haven't added the
Okay.
negative one yet. We just do it step by step. Start from something easy, then we add more and more detail.
Sorry.
Okay, thank you for asking. How about we 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9. You see, it's gradually shrinking. So why does the shrinking happens? Okay, so why does the shrink happens? Okay, let me switch to my document camera and I explain to you on paper why does the shrink happens. Okay, this is our original graph without shrinking. When x is pi over 2, sine x is 1. Okay, so this sine pi over 2 is 1. However, we have 2 times x here. Two times x. Let's use a box to represent x, okay? In order to make this value 1 for the same y coordinate, originally it takes this point. In order for the same y coordinate, what do we need to put here? Anyone has any idea? We want to make this value to be 1, 2 times something, sine 2 times of something equal to 1. What should we put here?
1/2.
For here it is 1/2 for this thing in total. However, this thing in total is 2 times this. So what should we put in this box?
1 over pi.
Let's figure out.
1/4, right? No,
Okay. Let's solve it. This whole thing is pi over 2. So 2 times this guy is pi over 2, okay? Do you guys agree? This just represents the unknown variable. Divide both sides with 2. So it's pi over 2 divided by 2, which is pi over 4.
I think we have to put pi over 2.
I'm sorry. What do you
We
say?
have to put the pi over 2, right?
We want to find a value here which makes sine 2 times this value equal to 1. Okay. And we know originally sine pi over 2 is 1. So in order to make this to be 1 again, 2 times this guy has to be the same with pi over 2. Okay. So 2 times this guy is same with pi over 2. And this guy is just half of pi over 2. Okay, both sides divided by 2. Any question on this one? How we get this value? Okay, so originally we have to put pi over 2 there, but now for the new function, it attains its max value at 1 when it was just half. Okay, originally it attains 1 here, but now it attains much earlier, only at a half of the price. So this is just one of the point. How about the other point? Originally, we have to sine pi over 6 equal to 1/2. Again, sine 2 times this value equal to 1/2. We need to find a new value which makes it 1/2. You do it exactly by the same process. You find that 2 times this box is 6 pi over 6. So this guy must be half of pi over 6. Pi over 6 is here, half pi over 6 here. Half pi over 6 is here. Originally the point is here. So now you see, for every point with the x coordinate here, you just get half here. Similarly, in order to attain the y value here, you just need half, because half of it. So that's why the curve is shrinking. Originally, the curve looks like this. Okay, this is the original graph. No, it looks like any, but it's shrinking. Look at my hand, shrinking, shrinking. Because we just need half of the value to achieve what we done. Now you need half of the x value to achieve what you have done here. So what you originally need pi over 4, now you just need what do you originally need pi over 2 to be done at this point? Now you only need pi over 4 to achieve that at the same point. Originally you need pi over 6. Now you only need a half of pi over 6. So that's why you just take half of the x value, then you get to the same y value. And the curve is shrinking this way. Okay, any question? How wide is shrinking? Okay, I know. I think some of you may still have questions, but you might be hesitating to ask. Don't
Did it
worry.
shrink times 1/2?
I'm sorry. What did you say?
Did it shrink because it's times 1/2?
Yeah. Basically, every x coordinate is times 1/2.
Okay.
Yeah, to achieve the same y value. So that's why it's shrinking. Okay, look at box equal to 1/2. Box equal to 1/2. Okay, so I know still some of you may have questions and you feel shy to ask here. Feel free to ask me after class, okay?
Is
Yes.
this nothing gonna be what we're gonna do in quiz 2?
No. The quiz 2 covers what we learned in the previous week.
Okay, thank you.
Okay, so let me repeat. Every week we do a quiz which covers what we learned in the previous week. Okay, don't worry about that. So let me show the screen. Share the screen with you. This is our syllabus. As you can see, this is our syllabus. If you scroll down, you see our schedule. We are following this schedule. Today is February the 4th. Quiz 1 covers what we learned in the first week. Quiz 2 covered what we learned in the second week. Okay, you see the section number. That's it. So everything is pretty straightforward, following this pattern. Okay, any question? And the best way to prepare for the quiz is have a review of your class notes of those weeks, or read your textbooks examples. My questions are extremely similar with their questions. Okay, just let you aware. Okay, any question before we continue on my lectures?
You said quiz 1, 7.2, 9.1, 7.1?
Yes. Quiz 1 corresponding to week 1, quiz 2 corresponding to week 2, so on and so on. Okay, very straightforward.
Okay.
Thank you for asking. Let's continue to our lecture notes. Okay, after we understand why it shrinks, because everything, the box always times 1/2, so that's why it's everything is shrinking by 1/2. Next, we need to understand how would this negative sign affect the graph of the sign. Originally, you have positive 1 here, right? But you times the negative sign. So all of your original value flip to the other side. Okay, all your x value flip to the other side. Originally, you have a negative 1 here, but you times the negative 1 here, so it flip up. So you basically flip the graph by the x-axis. If you have positive, now you have negative. If you have negative, now you have positive. That's it. Okay, let me show you on Desmos why this looks true. Y equal to sine x. Y equal to negative sine x Okay. So originally you have this red line. After you adding a negative sign to the front, what do you originally have here? You flip to the other side. Look, those positive value just flip to the other side. And those negative values just flip to the positive side. Okay? Any question why they are flipping? Okay, so let's go back to the next notes. Here you are times 1. The amplitude does not change. It just flip the sign, right? In this case, you are multiplying with -1, so the amplitude is still absolute value of -1, which is just 1, which is always 1. Okay, you just flip the sign, you didn't change the numbers. The coefficient of x about the period of graph. Now you are multiplying with 2. So everything shrinks by 1/2, okay? You see, we multiply 1/2 here, 1/2 here. So originally the 2 pi is 2 pi, the period. Original period, 2 pi. Now you multiply by 1/2. So the new period is 2 pi times 1/2 is pi. Okay? Any question on this one? Okay. So when this class is over, please have a review what we learned. I know things looks weird at the first glance. Similarly, we can do the same thing for our cosine function. But cosine is different. Still, you have the unit circle. Cosine corresponding to the x values. Okay? Cosine corresponding to the x values. When you have a terminal point here, the angle is 0. Can anyone tell me what's the x coordinate for this point? Hello, Mindy, I didn't hear you. Can you speak louder?
Is it 1?
Very good. Okay, thank you. This is cosine 0, 0 degree or 0 rating is 1 because the x coordinate of it is 1. So when x is 0, y is 1. So you start from the very high value here. Then, next question is, what is cosine pi over 6? What is the pi over 6 at this value?
Square root of 3/2.
Very good. So for a new angle, pi over 6, the x coordinate of it is here. You can do the same, exactly the same process as we did for sine. So it's square root of 3/2. Okay. How about the cosine pi over 3?
1/12.
Very good. This time you're moving a little bit higher. This angle is pi over 3. The x coordinate for this point is 1/2. So the y value is 1/2. This is pi over 3. This is 1/2. What if we successfully made it here? What's the x coordinate for this terminal point?
0.
0. Yeah, good. 0. Okay. Now you can connect those points. Okay. Similarly, you can do the same thing for those points below. Okay. I will leave this to the next class. So we are approaching to 9 o'clock. So I want everybody to log into your Canvas and to get ready to download your quiz 2. And please share your screen, share your desktop with me. I was switching around to see what you are having on your desktop. And do not cooperate with each other on the quiz, please. Do your own job. If you have any question about it, let me know. Okay? Okay, so it's 9 o'clock. I think the quiz is available. Please download it. This quiz was designed to be a 15-minute quiz. However, since this is our first time doing the in-class quiz, I'll give you 20 minutes extra. Okay, so that you can familiar with the process. And if you need any assistance, let me know.
So
Okay,
this is where we
Carlos.
start sharing our screen, Professor?
Yes, please share your screen, share your web browser, share everything you can share with me.
When you click share screen on the bottom, it says that the host disabled participant screen sharing.
Thank you for reminding me. I'm loving it right now.
Okay, thank you.
Everybody share your screen, share everything with me, and start working on your quiz. Okay, you can just write on a white paper, A4 size white paper, A4 size white paper, scan it, upload it as PDF. So do not overthink about the question. Every question can be solved by the knowledge we had in this class. For the first question, write them in square root, do not write them in decimals, okay? If you write them in decimals, it means that
Professor?
yes.
It is saying that there's an error for me to share my screen and it's not letting me.
Let me try to figure that thing out. Okay, thank you. Thank you for letting me know. Hey, Cody. Cody. Hello, Cody Russell. Hello, Cody.
Yeah.
We're doing quiz 2, not quiz 1.
Oh, crap. Okay.
No worry. Just let you know.
Hello, Professor.
Yes.
We have to write in the paper or just type in it?
Write any paper, scan it, and upload it as a PDF, please.
Okay, thank you.
Any white paper would work. just write cleanly on any white paper would work. As long as I can see your solution, that would work. We're doing quiz 2, not quiz 1. Okay, everybody, do not cooperate.
How do you want us to show our work for finding something like sine of 60?
You can just write the answer.
Okay.
Yeah. Yeah, we did it in class already, so you can just write the answer. The quiz are supposed to be simple. It is supposed to be simple, so do not overthink about it. If you can get the answer in one step, just get it in one step. Don't worry about it. So if you cannot share a screen, since this is our first time doing it, don't worry about it. I believe on the bottom bar of your Zoom, there should be a button, share a screen. I believe there you can share it. And do not leave before the end of the class. I'm taking the attendance also.
Is it okay if I write it down on a separate piece of paper and then scan it after class on a different one, just so I don't really have any paper that on hand right now?
No problem, but make sure you do it before 9:35.
Okay, thank you.
Okay, no problem. I'm super flexible and trying to be as helpful as you do. Okay, just let me know if you need any assistance, any question. So if you cannot share a screen, find the share screen button in the bottom of the Zoom. Let me know if you need any assistance. Feel free to ask me any question. Do not overthink about it. Every question should be simple. Every question should be simple. Write them in square roots form. Do not write them in decimals. If you write them in decimals, it will look very long, very ugly, and I know you are using a calculator. That's kind of self-proving that you are kind of cheating. So do not write them in decimals, write them in square root.
When does this find the exact value of each of the following? What exactly like would the exact value look like? Would it be like a whole number or what would it be?
Okay, so for the first question of the exact value, you see 450 degree, right? Minus that by 360. Do you get something similar?
Yeah.
So what do you get after you minus 360, the period?
90.
So what is sine 90? Don't say that answer, you know it already.
Yeah.
Okay, so this question tests your knowledge about the periods. So try to use periods. Okay, and this part B of the question has a negative sign. So the negative sign, you should think about can you get rid of the negative sign? If you can get rid of negative sign inside the sign function, do you need to put a negative sign to the front? Think about that. Or you can always use a unit circle to help you think about it.
Okay.
Circle, if you see a negative angle, what is the y coordinate? Sine corresponding to the y coordinate, right? Yeah. Yeah. Cool. Feel free to ask me more questions.
Professor, so if we finish, should we just go ahead and start trying to upload it now?
Yes, please. If you finish, please upload it.
Okay.
And after you upload it, feel free to go. Stay here only if you have questions. If you have finished, please upload it. If stay here if you have questions, only if you have questions.
I have a quick question. For
Yes.
g of number 1, what exactly is like the 2 over the tangent or the 2 over the sine mean?
I'm sorry, for which question?
For 1c,
1c. Yes. What is your question?
what does a 2 over the tangent mean? And like
2 over.
sine.
That means squared.
Okay.
Squared.
So
Okay.
just square the whole thing or just
Yeah,
square
square the whole thing. Square the
Okay.
whole thing. If you take a tangent, you get a value. Then make sure square that value.
Okay.
Oh my god, I thought it was 2 pi over 3.
Okay. Do not disclose your answer, please.
Oh no, I thought that c was tan 2 pi over 3 plus sine 2 pi over 6.
Okay. Cool.
So it's not that what you're saying? It's tan squared pi over 3 plus sine squared pi over 6.
I do not get what you were talking. Can you speak slowly again?
For
Yeah.
1c, is it tan 2 pi over 3 plus sine 2 pi over 6, or is it tan squared pi over 3 plus sine squared pi over 6?
So for 1c, you first find the tangent pi over 3, then you square that value. Then you find the sine pi over 6, then you square that value. You got two values, then you add up together. That's it.
Okay, thank you. I just thought it was different.
Did I answer your question clearly?
Yeah, thank you.
Okay, thank you for asking. Feel free to ask more questions. So stay here only if you have questions. Otherwise, please upload your quiz and feel free to go. And don't forget that we have a project due today also, at the end of today, I think.
So when we finish, we can leave.
Yes.
Okay.
After you finish, please upload it and leave. Stay here only if you have questions. Thank you.
Hi, I have a question about the application project.
Oh, yes, please.
So I was confused on number 2 because
Yeah,
it's
can you please share
asking
your
us,
screen
yeah.
and point where you feel confusing about?
Can you see my screen? Is it showing up?
Yes.
Okay. So like here, when we're finding the radius, because it doesn't give us an angle or like a point.
I'm sorry. Andrea? Oh, who just asked me the question? Can you please tell me your name? I can.
Alicia.
Alicia.
Yeah.
I have so many screens here, so let me
Okay.
find your screen. Oh yeah, yeah. Please continue your question. I found your screen already.
So I see how we have to find because we get the hypotenuse and we're looking for r, but I don't understand how to solve for it because we're only given 10.
Okay, cool. So you are not solving it completely. Let me show you on your screen.
Do you want me to stop sharing or?
No, don't worry.
Okay.
Don't worry about that. Let me share my screen. You can switch to my screen while also sharing your screen. Hey, Alicia, can you see my paper?
Yeah.
You have theta here, 10 here, r here, right?
Mm-hmm.
Radius is just this r. The question basically just want you to find this r. And you know there is a relationship between theta and r and 10. Sine theta is r over 10.
Mm-hmm.
Right? So multiply both sides with 10. 10 times sine theta equal to r. And that's it.
Okay. I didn't know if you wanted us to solve it fully or.
Yeah, that's it. All you need to do. You find r in terms of theta. That's good enough.
Okay. And then
Okay.
you just do the same thing for h in the next one.
Yes, yes.
Okay, thank you.
You're welcome. Do you have other questions?
No, I think that's it.
Okay, cool. So enjoy your day.
Thank you, you too.
Bye.
Bye.
Hello, guys. Did you finish your quiz? I see you are still here. So many people.
Try to upload it.
Okay, please upload it.
Hey, Professor.
Yes.
So with C, I don't remember how we did C. I'm trying to get that scan to you before like the deadline.
Yeah.
But for future reference, I'm gonna do the scan real quick, but after that, can we go over how we do that one? Once
Do
I
which one?
send B and C, those are the ones I was struggling the most with.
Question 1 on the quiz.
Yeah.
Okay, we can do that.
Yeah, let me just scan my quiz first so I could. I'm gonna stop my screen share. I'm trying to submit it, Professor, but it's saying that the type of file that I have is not allowed.
Did you upload it as a PDF?
Okay.
PDF, please. Do you have Adobe Scan?
I don't have Adobe.
Please try to. Okay, let me tell you this. I think you are past due already, but this is our first time doing it. I understand you may have difficulty doing that. I'll give you extension. Please upload it by the end of today. Please install Adobe PDF and upload your files by the end of today. If you cannot upload in the Canvas, please send me an email to attach your PDF in the email. Is that okay for you?
Yes, that's okay. I'm
Do
trying
it by the end of today, okay?
by the end of the day. Okay.
Okay, no, so do you have other questions which I need to address right now?
Yes, can you just well, it's in regards to it's in regards to the quiz. I don't understand when we did like basically question 3.
Question 3 about
With
quiz
like
of
the square,
which one?
with the square roots.
About the quiz today?
Yeah.
Question, we were talking about question 1, part 3, right?
Yeah.
Okay, let me show you.
So I just submitted my assignment so that it doesn't show up as like.
Let me show you. Please look at my shared screen. is tangent 3 pi, okay, squared plus sine pi over 6 squared. This is a question. Do you agree?
Yes.
Okay, so on the question I write it squared here, it just means squared here, okay? That's what I mean. That's the standard notation to write squared here, but to be clear for you, I just write it in this one. So tangent pi over 3 is sine pi over 3, right? Over cosine pi over 3. Do you agree? Lucia?
Yes, yes, I agree.
Yeah, what is sine pi over 3? Square root of 3 over 2, right?
Mm-hmm.
What is cosine pi over 3? Is 1 over 2, right?
Yes.
So this divided by this, you just get a square root of 3, right?
Yes.
So inside you have square root of 3. So square root of 3 squared is just 3. Do you agree?
Yeah.
For this part. Look at what do you have here? Sine pi over 3. What is sine pi over 3?
Sine pi over 3 is...
Over 6. Sorry, over 6.
Oh, over 6. Sine pi over 6 is... Isn't it... Give me 1 second. Let me look at the unit circle. 1/2?
Very
Oh, wait.
good.
Yeah.
You're right, 1/2. So what is 1/2 squared?
Wouldn't it just be 1?
No, 1/2 squared.
I don't know.
Okay. So this is your job. Figure out it. What is 1/2 squared? Then 3 plus 1/2 squared is the final answer. Okay?
Okay.
Okay. Thank you.
Thank you.
Any question I can help you?